This achievement represents a remarkable advancement in hydraulic engineering, dating back more than 2,000 years. The project not only enabled water to be directed against natural gradients, but also allowed vessels to ascend elevated terrain. The original purpose of this extraordinary hydraulic construction was to establish a navigable connection between the Li River and the Xiang River. At a carefully selected site along the riverbank, a short canal was excavated, followed by modifications to the natural riverbed. This effort ultimately produced a transportation waterway extending over 30 kilometers, later designated as the South Canal. Initially, however, the South Canal remained dry, preventing navigation. The difficulty lay in the fact that the canal entrance was situated at a higher elevation than the natural river level, which impeded the inflow of water. To address this problem, a dam was constructed at the canal's entrance, designed in a V-shape with an inclination of 108 degrees. The left side contained a smaller spur dike, while the right side contained a larger one. This structure effectively raised the water level, permitting the diversion of water into the South Canal. Nevertheless, the design was vulnerable. During periods of flooding, the dam faced a high risk of collapse. To safeguard it, an additional spur dike was constructed upstream of the dam. This feature functioned in a manner comparable to the overflow weir of the Dujiangyan irrigation system, dividing the current into two channels. Consequently, approximately 30% of the floodwater was retained and directed into the South Canal, while the remaining 70% continued along the Xiang River, thereby regulating water levels in a natural and balanced manner. Although the dam successfully stabilized water inflow, it simultaneously obstructed the Xiang River's natural navigational route. To resolve this, an auxiliary waterway was excavated to the east of the dam. Designed in an S-shaped pattern to slow the current, this channel facilitated stable vessel passage and came to be known as the North Canal. During flood seasons, abundant water allowed for smooth navigation. In contrast, during drought periods, when the river's discharge diminished, water levels became insufficient to sustain both canals, resulting in interruptions to transportation. To ensure reliable navigation, sluice gates were installed at the entrances of both canals. By closing the North Canal gate, water was directed toward the South Canal whenever passage there was required. However, the South Canal's elevation posed another obstacle. Vessels could not ascend the higher levels directly. To overcome this, a system of 32 sluice gates was constructed. By sequentially closing the downstream gates and allowing the water level to rise, boats could progressively move upstream, in a manner akin to ascending by means of a hydraulic lift. Conversely, when traveling downstream, controlled release of water enabled vessels to descend gradually and smoothly. This technological innovation predates Western canal lock systems, such as those later employed in the Panama Canal, by more than 2 millennia. The hydraulic marvel became known as the Lingshu Canal. Its construction provided a vital military supply route linking the Central Plains with Lingnan, thereby playing a decisive role in Emperor Qin Shi Huang's successful unification of China.